Welcome back to Math Geeks and Science Freaks. In today's lesson, we're going to cover the Pythagorean Theorem. The first thing you need to know is that the Pythagorean Theorem only works on right triangles. Of course, right triangles means that there is one right angle, which equals 90 degrees. We also need to know which side is the hypotenuse, and that's always the side opposite of the 90 degrees, which is also the longest side of the triangle. The equation for the Pythagorean Theorem is a squared plus b squared equals c squared, where a and b are the legs of the triangles and c is always the hypotenuse. So this side would have to be c, as it is the hypotenuse, the longest side, which is opposite 90 degrees. The other two are interchangeable. It doesn't matter which one is a and which one is b, as long as these are the two legs of the triangle as opposed to the hypotenuse. The Pythagorean theorem helps us find an unknown side of a right triangle. In that case, we would need two sides of the triangle to begin with. So if we have our right triangle with a side length of 3 and another of 4, and our hypotenuse is the unknown, we'll leave that as c, then we can substitute the sides of the triangles for a and b. So we would start with 3 squared plus 4 squared equals c squared. 3 squared is just 3 times 3, which would be 9, plus 4 squared, which would be 16, equals c squared. 9 plus 16 gives us 25, which equals c squared. And to get c, which is the value of the hypotenuse here, we just need to take the square root of both sides. The square root of 25 is technically positive or negative 5, but since we're dealing with length here, then of course it'll only be the positive 5. So 5 is equal to c. As far as the units, those do not matter. If it was 3 inches and 4 inches, then the hypotenuse is 5 inches. If they were meters, it would all be the same. If it was miles, same thing. Let's look at another example. We have our right triangle. Let's say one of the sides is 6. And let's say this is our unknown here. We'll call this one b. And our hypotenuse here is 10. Remember that the hypotenuse is always our c value. And the legs, again, either one could be a or b. This could have been a. It really doesn't matter. Using our formula, we'll have a squared, which in this case is 6 squared, plus our unknown b squared must equal c squared, in this case 10 squared. So here we have 36 plus b squared is equal to 100. And now we'll just use basic algebra to solve for b squared. We want to isolate b squared. To do that, we'll need to subtract 36 from both sides. We end up with b squared is equal to 64. And to get b alone, we'll need to square root both sides. And now we have b is equal to 8. So anytime you're using the Pythagorean theorem, you just need to make sure that you're setting the hypotenuse, the longest side, which is opposite of the right angle, this side. Make sure that's always on the other side of the equation. It's this leg squared plus this leg squared equals the hypotenuse, or longest side, squared. Sometimes you'll be given a triangle without any angles, but you'll have the 3 sides, and you'll be asked to determine whether or not it is a right triangle. So if we have sides that are 3 and 5 and 6, we can use the Pythagorean theorem to determine if this is a right triangle. We can figure out which of these 3 angles would need to be 90 degrees, and that would be this one, because it is opposite of the largest side, and therefore this angle would have to be larger than either of these 2 other angles. And of course, since a triangle adds up to 180 degrees, there can only be one angle that's 90 degrees or more. Knowing that this would have to be our right angle if it is, that means that our 6 is going to equal our c value. And again, either of these could be a or b. Let's make 5 our a, and let's say our 3 is b. Using our equation, we have 5 squared plus 3 squared needs to equal 6 squared for this to be a right triangle. Anything else means it's not. 5 squared is 25. 3 squared is 9. And 6 squared is 36. So we need to add 25 plus 9, and that gives us 34, which does not equal 36. It's close, but this means that this angle over here cannot be 90 degrees. Let's take a look at one more example. Again, we're going to be asked whether or not this is a right triangle. It may look like one, but we'll have to determine that algebraically. If one of the legs is 5, the other one is 12, and this last one is 13, then again, we can deduce that if there is a right angle, it would have to be over here, as it is opposite of the largest side. That means that our 13 would have to equal our C. And again, the 5 and the 12 either can be A or B. So let's make A equal to 5, B equal to 12. All we have to do is plug it into our formula and see if both sides equal each other. So we have our A squared, which is 5 squared, plus B squared, which is 12 squared. And we need to see if that's going to equal our C squared, which is 13 squared. 5 squared gives us 25. Our 12 squared gives us 144. And 13 squared gives us 169. 25 plus 144 equals 169. So here we have both sides that equal each other. A squared plus B squared equaled C squared. And therefore, this angle is definitely a right angle, meaning that we have a right triangle. Thanks for watching. If you found this video helpful, please give it a big thumbs up and subscribe for more videos.